Hello everyone. Once again, welcome to PM Networking. Hope you all are doing great. Guys, today in this video, we are going to understand real-time network troubleshooting. See, this is my scenario and this scenario is completely based on real time. First of all, guys, let me make you familiar with this topology. Then we will move to the troubleshooting part. See, in this scenario, I have two customers, customer 1 or customer 2. Customer 1 is Lenovo, customer 2 is HP. So this is side 1 of Lenovo, or you can say side 1 of customer 1. This is side 2 of Lenovo, or what you can say side 2 of customer 2. This is side 1 of HP, and this one is side 2 of HP. Fine guys, you can see in Lenovo networks, in Lenovo side 1 and side 2, we are running dynamic routing protocol, that is RIP version 2, and in HP customer, we are running dynamic routing protocol EIGRP number 100, and both customer side are connected with each other through service provider network. So this is service provider network, right? R1 and R2 both are PE router. Okay, provider is 1, you can say provider is 2. Router 3, router 4, router 5 and router 6, these are CE router, customer is routers for service provider. Fine. Between side 1 of Lenovo and PE router means R1, we are running this network. Between R1 and R4 this network. Between R2 and R5 this network. Between R2 and R6 we are running this network, right? In the LAN, here we are running this network 10.1.1.0/24 in Lenovo side 1. In Lenovo side 2, we are running this network 20.1.1.0/24, and same network I am running in HP sites as well, like in HP side 1 10.1.1.0/24, in HP side 2 20.1.1.0/24. Now guys, this topology is pre-configured, right? Everything is configured over here, but problem is customer side 1 and side 2 are not able to communicate with each other. Lenovo side 1 users are not able to ping Lenovo side 2 users. In the same way, HP side 1 users are not able to ping HP side 2 users. So there is some misconfiguration in service provider network, right? So that we need to find the problem and then we need to troubleshoot it. Okay guys, so without wasting our time, let's begin. First of all, I am going to verify the problem. I'm going to ping from PC1 to PC3, and then I will ping from PC2 to PC4. If really ping is not working, then we will start the troubleshooting. We will start troubleshooting from router number 3 first, because 20 network should be in the routing table of R3. In the same way, 10 network should be in the routing table of R5, right? Then only these two sides can communicate with each other, right? After that, we will verify the configuration on R1 and R2, then we will troubleshoot it, guys. Okay, so see, I have access of all devices here in secure CRT. Now this is PC4. Okay, this is R1, router 1, router 2. So you have one log message as well here. LDP neighbor 10.10.10 is done. Okay, we will see this log message and problem. This is router number 3, router 4, router 5, router 6, and I have router 6 twice, so let me close it. And then PC1, PC2, PC3 and PC4. First of all guys, from PC number 1 I am going to verify the IP configuration over here. So IP, I can say all. So IP address of this PC is 10.1.1.10/24, correct as per the diagram, and the gateway IP address is also 10.1.1.1, that is also correct, right? Let me ping the gateway, ping 10.1.1.1. so you can see I'm able to ping my gateway IP address. Now let me verify the IP on PC number 3, right? PC3, here is PC3 connected with router number 5, right? PC3 is in the side 2 of Lenovo customer. So here, so IP all. On this PC also you can see IP is 20.1.1.10, correct as per the diagram, and gateway IP address is also correct as per the diagram, right? 20.1.1.1. Let me ping the gateway, ping 20.1.1.1, and you can see I am able to ping my gateway. Now from PC number 1 I am going to ping PC3 directly. Let me ping 20.1.1.10 from here. So you can see ping is not working, and what error I am getting, guys? Request timeout. Fine. So you will start troubleshooting from router number 3. So as I told you, first of all I will verify the routing table of R3, because router 3 should have 20 network in their routing table. So let me take you to R3 and here. And you know guys, before starting the troubleshooting, in the same way you can verify the problem in HP customer as well, in HP networks as well, like PC number 2. PC number 2 is also not able to ping PC number 4, 20.1.1.10. So see, this PC is also not able to ping. Fine. Now let's begin troubleshooting from router number 3. First command that I will run over here is show IP route directly to check the routing table. Or before running this command, you can verify the IP configuration as well, like maybe default gateway configuration is wrong, or some IP addressing configuration is wrong. So IP interface brief, I can say screwed unassigned. So IP on fast Ethernet 0/0 is 13.1.1.3, correct as per the diagram, and on fast Ethernet 1/0 10.1, this is also correct. Now let me verify the routing table directly. So IP route, yes, see guys, in the routing table we have 20 network, 20.1.1.0/24 network, right? And this router is learning this network through which routing protocol? Through RIP routing protocol. So IP protocol summary, here we are running RIP routing protocol, right? So run section RIP. So we are running RIP version 2 here, you can see. Fine. So through RIP routing protocol I am learning 20 network, right? So 20.1.1.0/24 network is there in the routing table of R3. Okay. Or you can run this command, so IP route. So IP route RIP, right? It will show you only RIP routing protocol routes here, right? In the same way guys, on router number 5 we should have 10 network, 10.1.1.0/24. So let me take you to R5, and on R5 also I'm going to run command show IP route. And in the routing table of R5 you can see I am getting this network 10.1.1.0/24. So IP route RIP, you can run this command, right? So see, I am learning this network here on R5. That means side 2 edge router have all the prefixes of side 1. In the same way, side 1 edge router means this CE router have all the prefixes of side 2, correct? But still ping is not working. So what you can do here is you can do trace route as well guys, trace and 20.1.1.1. So my traffic is going to 10.1.1.1 means my edge router, and after that my traffic is going to 13.1.1.1 means router number 1, and my router 1 is dropping the traffic, right? From router number 1, after router 1 I am not able to find the path, right? So directly I am going to check the routing table of R1 now, PE router. So let me access R1, right? Maybe in real time you will not have access of service provider network, so you will complain to service provider, and your service provider engineers will troubleshoot their network. So see how service provider network engineer will troubleshoot R1 and R2. First again they will run what command? So IP route, but this command will show you the global routing table of R1, right? But as this is PE router, we will have multiple VRF over here, we will have MPBGP configuration between R1 and R2, so we need to troubleshoot those all things. And as we have to configure like MPLS as well between R1 and R2, and LDP neighborship should be there. So there was one log message that LDP neighborship is down, so we will see that also. But this is guys global routing table of R1. In the global routing table we have this network, then 2.2.2, 10 dot and 12, right? This is directly connected network, and I think 2.2.2 it's learning 2.2.2 from OSPF protocol. So I am using OSPF as IGP protocol under service provider network. And again 1.1.1 is directly connected, 10.10.10.10 is also directly connected. See, when router 1 will receive traffic on this interface, like what I am saying, when PC1 will ping to 20.1, source IP address is going to be what? 10.1.1.10. destination IP address is going to be what? 20.1.1.10, right? PC will forward traffic to router number 3, router will forward it to router number 1. Now router number 1 will receive this traffic on this particular interface. Getting my point? So now router 1 will check that this receiving interface is member of which VRF, so that you can run command over here, so IP VRF. So you can see guys, fast Ethernet 0/0, fast Ethernet 0/0 is member of which VRF? Is member of VRF Lenovo. So now R1 is going to check routing table of Lenovo VRF. It will run this command. So IP route VRF Lenovo. Okay, and you can see guys, in the routing table of Lenovo VRF we have 20 network, 20.1.1.0, right, side 2 of Lenovo, right, and I have 10 network also, 10.1.1.0, and router number 1 is learning 10 network through RIP routing protocol, and this network 20.1.1.0/24 from the BGP protocol, right, like between R1 and R2 I am running MPBGP. So through MPBGP it have learned this network 20.1.1.0. Okay, so now on router number 1 you are able to see route, right, in the routing table route is there. So when router 1 will receive traffic on fast Ethernet 0/0, it will check this routing table. So IP dot VRF Lenovo. When in the same way router 1 will receive traffic on this interface on fast Ethernet 1/1, it will check which routing table? So IP VRF. It will check HP routing table, right? HP routing table. So IP route VRF, I can say HP. And here you can see guys, under HP routing table also we have 20 network as well as 10 network, right? So in the routing table there is no any problem, right? Routing table looks like fine on R1 as well and on R3 as well. If you want to verify, and you should verify again the routing table on R2 as well guys, I am going step by step so that you know you can also troubleshoot this kind of problem. Now on router number 2 also we need to verify the routing table for both VRF. So IP VRF, here also we have HP VRF and Lenovo VRF. Fast Ethernet 0/0 is member of Lenovo VRF and fast Ethernet 1/0 is member of HP VRF. So IP route, this is global routing table, and so IP route VRF and what we can say Lenovo. Okay, so you can see in the Lenovo routing table we have again 10 network guys through BGP. It is learning from R1, right? Router 2 is learning 10 network from R1 and 20 network from RIP routing protocol, 20 network from R5 through RIP routing protocol. In the same way R1 is learning 20 network through RIP routing protocol, through BGP routing protocol, and 10 network through RIP routing protocol. This is RIP, this is BGP, this is BGP, and this is RIP. This is how R1 and R2 are learning prefixes of side 1 and side 2 of customer 1, or you can say Lenovo customer. In the same way router 1 will learn this prefix side 1 prefix of HP customer through EIGRP S number 100 protocol, right, and it will learn this network 20 from router number 2 through BGP protocol, correct? And router number 2 will learn 20 network from EIGRP S number 100 and 10 network from BGP protocol through BGP protocol. Getting my point? Hope it is clear to you. So now on router number 2 guys, you can see we have 10 network through BGP and 20 network through RIP routing protocol. In the same way we can verify the routing table of HP, right? So IP route VRF, so IP route VRF HP. So here also you can see this router is learning 10 network through BGP and 20 network through EIGRP. So routing table of both P router provider edge routers like R1 and R2 look like fine, right? We don't have any problem till here. Now then why ping is not working? So now guys try to understand the packet flow, why ping is not working. See what will happen when router 1 will ping to, when PC1 will ping to PC number 3. Let me generate one traffic here. PC1 will generate a ICMP traffic with source what? ICMP source will be 10.1.1.10 and destination will be 20.1.1.10. PC will forward traffic to router number 3. Router 3 will check their routing table, right? In their routing table, yes, route is available, and via which router? Via R1 13.1.1.1. Actually router 3 will check this table, so IP safe, right? So IP safe, and then you can put the network as well, like destination IP address is destination IP address in the packet is this one, 20.1.1.10. so it is going to say 20.1.1.0. so IP sap 20.1.1.0, right? So you can see for 20.1.1.0 there is no route. Sorry, there is some misconfiguration. I have said 200, right? It's 20.1.1.0. Yes, for this network you can see next hop IP address is 13.1.1.1 and exit interface is fast ethernet 0/0, and R3 should have MAC address also of this IP address. So you can check. So IP ARP. So in the ARP table you can see this machine have already MAC address of 13.1.1.1. this is MAC address, correct? So on router number 3 everything is fine. Router 3 is going to forward the traffic from fast ethernet 0/0, from fast ethernet 0/0, right? Now router 1 will receive the traffic on fast ethernet 0/0, right, where source is 10.1, destination is 20.1. router 1 is receiving traffic on fast ethernet 0/0, which is member of which VRF? Lenovo VRF. So it is going to check this routing table. So IP route VRF Lenovo. So there is one route, but you know R1 will not check definitely this table. R1 will check SAP table. So IP SAP VRF Lenovo, because receiving interface is member of Lenovo VRF, and after that which network? 20.1.1.0. so guys, you can see the problem. What is problem over here? Problem is for this network 20.1.1.0/24, next hop is 12.1.1.2, exit interface is serial 2/0, which is unusable, and there is no any label for this network, right? So R1 don't have any label for this network for 20.1.1.0/24 network, right? So MPLS, you can say forwarding table. Yes, you can see in the forwarding table you don't have any label for 20 network, and so run interface serial 2/0. See, MPLS is enabled on serial 2/0. So if router 1 will forward traffic from serial 2/0, it will add the label, right? So what is the local label? So MPLS forwarding table. So there is no any local label or remote label for 20 network. So MPLS LDP binding, you can check the binding table also. Here also you can see, fine. Why we don't have any label for 20.1.1.0 network? So MPLS LDP neighbor, because you can see, right, there is no LDP neighborship between R1 and R2. And that's why you had seen one log message that LDP neighborship is down. Okay, so if we don't have LDP neighborship between R1 and R2, these two routers cannot exchange labels. So if these two routers cannot exchange label, guys, how router 1 will get label for 20 network and how router 2 will get label for 10 network? This is the problem, right? Maybe because of this reason side 1 and side 2 are not able to communicate with each other. So MPLS LDP binding VRF say Lenovo. Okay, so MPLS LDP discovery, right? So you can see, guys, LDP identifier of this router is 10.10.10.10, and it is discovering one neighbor on which interface? On serial 2/0. It is discovering one neighbor on serial 2/0, and neighbor router ID means LDP identifier is 20.20.20.20, and no route available, right? So R1 don't have any route for this IP address. So IP route, right? You can see we don't have 20.20.20.20 in the routing table of R1, right? So R1 cannot forward LDP hello message to router number 2, right? Or what you can do here? You can debug MPLS LDP transaction events, let's say, right? So it will show you the messages that it is forwarding any message or not. Yes, you can see it is receive LDP hello on which interface? On serial 2/0 from 12.2, and LDP identifier is 20.20.20.20, right? So it is receiving hello message, LDP hello message, as well as it is send LDP hello from serial 2/0, right, with LDP identifier what 10.10.10.10. Okay, let me do on all here. Because of this, guys, you don't have MPLS LDP neighborship here, right? And if you don't have MPLS neighborship, right, we cannot exchange labels between R1 and R2. And same thing is happening on order number 2 as well. Like here, if you will debug MPLS LDP transaction events, so you can see, right, this order is also receiving as well as sending LDP hello message, but there is no root available, right? So say on all and so MPLS, what we can do, LDP, let's say discovery. So you can see it is also discovering one neighbor 10.10.10.10, right, but route is not available. So MPLS is enabled on serial 2/0 on both router on R1 and R2. You can run this command. So run interface serial 2/0, right? You can see we are running this command here, MPLS IP, or you can run command so MPLS interfaces, right? It will show you the MPLS enabled interface. So serial 2/0 MPLS is enabled over here. Getting my point. On router number 2 also show MPLS interfaces. So MPLS is enabled on serial 2/0. Okay, but guys, as we don't have route, right, for the LDP identifier, neighbor LDP identifier, right, we are not able to exchange labels. Okay, so on router number 2, so MPLS forwarding table, right? So you can see here we have one label, local label, that is 200, right, for 20 network. On router number 1, so MPLS forwarding table, we have one label for 10 network, right, that is 100. But router 1 need to share this label to router number 2, and router 2 need to share this label to router number 1. How routers share, guys, labels? With the help of LDP protocol, and we don't have LDP neighborship here, right? So this is the problem. Now you need to troubleshoot why there is no reachability between 10.10.10.10 and 20.20.20.20. First of all, on R1, so IP interface brief, right? So you can see we have two loopback interface. One is 1.1.1.1 and another one is 10.10.10.10, right? On router number 2 also, so IP interface brief, we have two loopback interface. One is loopback 1 where I'm running 2.2.2.2 IP, and one is loopback 10 where I'm running 20.20.20.20 IP. Getting my point? And so IP protocol summary, here what dynamic routing protocol I am running, guys? One is BGP 100, definitely between R1 and R2, that is MP BGP, and we are running OSPF 1 as a IGP protocol, right? So on router number 1 also, so IP protocol summary, you can use this command to find a dynamic routing protocol. We are running BGP as number 100 and OSPF process 1. So what I can do, I can check what network I am advertising in OSPF. So IP OSPF interface brief, let's say I can run this command. So you can see OSPF is enabled on loopback 1 and serial 2/0 only, right? So OSPF is enabled on serial 2/0 and loopback interface. In the same way on router number 2 also, so IP OSPF interface brief. So you can see OSPF is enabled on loopback 1 as well as on serial 2/0. So we are not actually enabled, or we are not running OSPF on loopback 10 interface, right? So that is the reason why routers are not advertising 10 and 20 network with each other. Okay, so in the routing, local routing table, in the global routing table, we are able to see here 10 network, right? But it will not advertise this network to R2 through OSPF because this network is not advertised in OSPF. Or the another option to check this is what I can run source section and router OSPF. So you can see what command I have run under OSPF, only these two commands, right? I'm advertising 1.1.1.0 and 12.1.1.0. That's it. On router number 2, so run section OSPF. So here also I am advertising only these two network, right? So what is the option, guys, here to troubleshoot, to fix it? To fix it, what I can do, I can change the LDP router ID on router number 1 and router number 2. I can tell to router number 1, please use 1.1.1.1 as a LDP router ID, or I can tell to router number 2 also that please use 2.2.2.2 as a MPLS router ID. This is first option, right? We can change the LDP neighbor ID, and this is the best option, right? In real time also you will do same thing. But the second option can be what we can do. We can advertise 10.10.10.10 network in OSPF on router number 1, and we can advertise 20.20.20.20 in OSPF on router number 2, so that these two IP addresses will become reachable with each other, and then LDP neighborship will come up. After that, these router can exchange label, and then hope these two sides can communicate with each other. So first let me do this guys method. Use this method. I'm going to advertise 10 and 20 in OSPF, and after that I will use this method. Okay, so see, on router number 1, go to router OSPF 1 and say network 10.10.10.10 to wildcard mask 0.0.0.0 and area 0. On router number 2, router OSPF 1 and say network 20.20.20.20 0.0.0 and say what area 0. Now I am expecting LDP neighborship between R1 and R2, right? So first of all let me check the routing table. So IP route OSPF, yes, now you can see I am learning 20 network here, and so MPLS LDP neighbor, yes, you can see the log message as well. LDP neighbor 20.20.20.20 is up, right? And you can see the neighbor table as well, right? Peer LDP identifier 20.20.20.20, local identity LDP identifier 10.10.10.10, and now we have reachability between 10.10.10 and 20.20.20.20. So that's why we have now LDP neighborship between R1 and R2. And now again on router number 1, if you will check, so IP SAF VRF Lenovo and network 20.1.1.0. Now guys, you can see for this network we have label, what label? 200, right? What label we have now? 200. Now in the same way for HP customer also we can check, right? So yes, for HP also you can see now we have label that is 201. Getting my point. On router number 2 also we can verify, so IP SAF VRF Lenovo and 10.1.1.0. yes, we have one label here, right? And for HP 10.1.1.0, yes, we have label, right? And you can run so MPLS forwarding table as well, right? Under forwarding table also you can see the label for 10.10.10.10, or not 10.10.10 for which network guys? Here I should check like this, not like this. This is global. Here we should have one label for 10 network. Okay, so here I can say VRF and then Lenovo, right? So you can see for 20.1.1.1 local label is 200, and on router number 1, so MPLS forwarding table VRF Lenovo, so it's local label over here, right? And this network is reachable from this. Okay, here we should have one more entry, I think. So MPLS, so IP SAF VRF Lenovo. Okay, and if you want to check the detail 20.1.1.0, so yes, you can see the label. And now guys, again I am going to verify the connectivity from PC1. Again I'm going to trace route 20.1.1.1, and let me check this time. Yes, you can see this time trace route is working fine. Traffic is going to router number 3, then router number 1, then it is forwarding to router number 2, and then router 2 is forwarding to router number 5. So let me ping again 20.1.1.10, and you can see this time ping should work. Yes, and now ping is working, right? Now ping is working. Now again let me take you to R1, and I am going to remove 10.10.10 from OSPF router OSPF 1, and network 10.10.10.10 255 sorry 0.0.0 area 0. I'm going to remove this command, say no to this, right? On router number 2, router OSPF 1 and network 20.20.20.20 0.0.0 area 0. Sorry, let me say no to this command. No. Fine. Again LDP neighborship bill goes down, clear MPLS LDP neighbor star, right? And so MPLS LDP neighbor. Now wait, so IP route clear MPLS LDP neighbor star, so MPLS LDP neighbor. Now you can see we don't have LDP neighborship. And again if you will check, so IP SAF VRF Lenovo and 20.1.1.0 you don't have label, right? Unusable. Okay, now I am going to configure, I'm going to force to router number 1 to use LDP neighbor ID 1.1.1. so what I will do for this, guys, config t and say MPLS LDP router ID loopback 1. Choose the router ID, the IP address which is running on loopback 1 interface, and say here force. Now on router number 2 also I have to run this command, MPLS LDP router ID loopback 1 and force, right? Now here if you will run command, so MPLS LDP, let's say discovery, right? So their router ID is this one, and soon their neighbor LDP identifier is going to be 2.2.2. yes, now you can see, right? And now again we have LDP neighborship. Why we have no LDP neighborship? Because there is reachability between 1.1.1 and 2.2.2, right? Because we have configured BGP through this loopback interface, right? And BGP neighborship is also up. So TCP brief, you can use this command as well for troubleshooting, guys. Like you can see we have two TCP connection between R1 and R2, one for BGP and one for LDP. Okay, and now again from PC number 1 if I will ping, let me check now ping is working or not. Yes, now you can see again ping is working. In the same way we can check HP side 1 and side 2 connectivity as well, connectivity between HP side 1 and side 2. I'm going to ping 20.1.1.10 and you can see ping is working fine. So this was just a small troubleshooting of, you can say what, LDP protocol, or you can say service provider network. Okay guys, so sometime in real time what is happening, we configured lots of loopback interfaces on routers, and LDP is picking any loopback IP address, maybe lower or loopback IP address, or you have configure to use a particular IP address of a loopback interface as a LDP neighborship, right? And that IP address is not reachable with each other. Because of that your LDP neighborship bill goes down, and routers, your PE routers cannot exchange labels. Because of that your customer will goes down, right? Because of that your customers cannot communicate with each other. Okay, so this is how you can troubleshoot this type of problem, guys. In upcoming time we are going to learn, we are going to understand many more troubleshooting tips, trick, right, and real-time scenario. So that's all for today. If you have learned something from this video, please hit on like button, guys. If you have not subscribed my channel, please subscribe the channel. We will meet soon in next video. Till then, stay safe. Bye bye. That's all for today.